In conserved. Conserved. Hope you understand. Total energy of the system will remain conserved. So suppose if this is a wheel, this is going in forward direction and rotating also. So if the object is having a translation and rotation both together, then if this object is having translation plus rotation together, then such type of motion is known as rolling motion. Such type of motion is known as rolling motion. And if object rolls without slipping or sliding, if object rolls without slipping or sliding, then its motion is called pure rolling motion. Its motion is called pure rolling motion. Is this all right? Its motion is called pure rolling motion. So if it rolls without slipping or sliding, means there is a translation plus rotation without slipping or sliding, then such motion is known as pure rolling motion. Is this okay? Pure rolling motion, this is all type of vehicles will have pure rolling motion. Generally they have pure rolling motion, except in some other cases, like when they suddenly apply the brake, isn't it, or the tire of the vehicles emerge inside mud, isn't it? In that situation there is a slipping, but in general when it walks on the road, when it travels on the road, there is no slipping of the rod on the road. Slipping of the vehicles on the road means slipping of the tire on the road. There is no slipping. Is this okay? That is example of a static friction. I have told you in a static friction as well. Is this okay, student? Now try, student, suppose this is having a motion in this direction, translation. Suppose its velocity is v and its angular velocity is omega, and if the radius is r, then if you consider this point is attached to the surface of the earth, isn't it? So there is no relative slipping between this point and this point. Is this okay? So what I will say, velocity of one and velocity of two will be same. What is the velocity of one? Can you tell me? 0. And what is velocity of two? So 2 will go in this direction with v velocity, and 2 will move in backward direction with omega r. Is this all right? So net velocity of 2 will be equal to v minus omega r. Is this okay? So that is equal to v is equal to omega r, you will get. So v is equal to omega r is the condition for pure rolling motion. Condition for pure rolling motion. Is this all right? Now, if you differentiate it, acceleration will be equal to alpha r. Is this all right? This is also the condition for pure rolling motion. Hope you understand. These are the condition for pure rolling motion. V is equal to omega r, acceleration is equal to alpha r. This is the condition for pure rolling motion. Is this okay? So in that situation, the friction would be a static, and we can conserve the momentum. We can conserve the energy, isn't it? So let me take example. So suppose Initially, I am taking a very easy example. Suppose this is the object, radius is 0.1 meter. This is going in this direction with a velocity of 10 meter per second and moving with omega in this direction. Find omega for pure rolling. Find radius if it is rolling purely. Now, this plank is moving in this direction with 10 meter per second. This is moving in this direction with 20 meter per second. Radius is equal to 0.5 meter. This is omega. So find omega if it rolls purely on the plane, on the plank. Is this all right? Do it. So first one is very easy, dear student. V is equal to omega r is the condition for pure rolling. Velocity is 10. Omega is not known to us. Radius is 0.1. So that will be omega is equal to 100 radian per second. Now here also V is equal to omega r. We will apply that in the second question. Velocity is given 20, omega is given 40, and this is r. So r will become equal to 0.5 meter. Is this all right? Now, this question is a good question. Not right. Its radius is 0.5. It is moving on this one, on this surface, on a plank, which plank is also moving with 10 meter per second in forward direction. So what is omega for pure rolling? Do it fast. Find by V and omega. if there is no sliding anywhere, if there is no sliding anywhere, then find velocity and omega. Do it first. Okay. So let me explain this one. So actually, if this is not slipping over this one, means this point is 1 and this is 2. Means 1 and 2 point are not slipping with respect to each other. What does it mean? It means that velocity of 1 will be equal to velocity of 2. So if you consider point 1, what would be its velocity? That is 20 meter per second in this direction, and in this direction it would be equal to omega into radius, that is equal to 0.5. So omega into 0.5, that is half, is equal to 20. So omega will be equal to 40 radian per second. Is this all right? Omega is equal to 40 radian per second. So this is the value of omega. Now here you have to calculate omega and v. So if you consider this point is 1 and this point is 2, this is not slipping with respect to each other. Is this all right? So that is equal to, no, I did a mistake at this place. Okay, friend. So this is net velocity of 1 in this direction is equal to 20 minus 0.5 omega. isn't it? In this direction, the net velocity of 1 is. And that has to be equal to velocity of 2. 2 is the part of the plank and its velocity is 10 meter per second. So it will be equal to 10. So 10 will be equal to 1 by 2 into omega. So omega is 20. Make the correction. Similarly, if you consider 1 and 2 point, velocity of 1 will be equal to velocity of 2. If you consider 1 point, it is going in this direction with 30 meter per second and it is moving in this direction with omega into r. R is 1 meter per second. So V1 is equal to basically 30 minus omega. And what is V2? Velocity of point 2 is equal to 10 meter per second. So omega will be equal to 20 meter radian per second. Is this all right? Omega is equal to 20 radian per second. Now, if I consider this point is 3 point and this point is 4 point. So velocity of third point will be equal to velocity of fourth point. Velocity of third point will be equal to 30 due to translation plus omega r. And omega r will be equal to not 30, that is 20 into radius is 1. And velocity of fourth will be equal to v. So v is equal to 50 meter per second. Is this all right? Copy it. Next question, suppose this is the desk. Its mass is m, radius is r. Is this okay? It is released from this place. Released from this place. And it from h height it is released. Is this okay? So it comes down, slides down, and it starts moving on the horizontal floor. Is this okay? Is this all right? So find velocity, find v in term of m r g h. Is this all right? Disk is having disk is rolling purely everywhere. Everywhere disk is having a pure rolling motion. Is this okay? Do it first. So how you will do it? So student, you have to conserve the energy. So here the potential energy is 0, consider. So here the potential energy will become equal to mgh. Is this all right? So initial potential energy plus initial kinetic energy will become equal to final potential energy plus final kinetic energy. Initial potential energy is equal to mgh. Initial kinetic energy is 0. Final potential energy is also 0. And final kinetic energy is half mv square plus half I omega square. This is translational kinetic energy. And this one is rotational kinetic energy. Is this all right? So that is equal to mgh is equal to half mv square plus half I omega square. I is moment of inertia is mr square by 2. Is this okay? Into omega square. What is omega? Omega is equal to v by r. V is equal to omega r. So omega is equal to v by r. So that is equal to v by r square. So v square by r square. So this one cancelled out. So that will become equal to mgh is equal to half mv square plus mv square by 4. So that m cancelled out. So this is gh is equal to 3 v square by 4. So here velocity will become equal to root under 4gh divided by 3. Hope you understand, student. Is this all right? This will be the velocity. Copy it. Do it fast. This is moving in this direction with v velocity, and this one is going in this direction with 20 meter per second, and moving with omega is equal to 10 radian per second, and its radius is equal to 1, and this is a disk. Its mass is equal to 4 kg. The mass of the plank is 2 kg. Find total kinetic energy of system. System means disk plus plank. Is this okay? Do it fast. Okay. So ये point 1 है, this point is 1 and suppose this point is 2. So velocity of 1 will be equal to velocity of 2. What is velocity of 1? So 1 will go in this direction with 20 meter per second due to translation, and in this direction with rotation, due to rotation it will move with v is equal to omega r, that is equal to 10 meter per second. So overall this point is moving in this direction with 10 meter per second. So v1 is equal to 10 meter per second, and what is v2? So that will become equal to v2. So v2 is also equal to 10 meter per second. Now what is total energy? What is the energy of the disk? Half mv square, that is 4 into 400, v square is 400, plus half I omega square, I is 4 into r square by 2, mr square by 2 into omega square, plus kinetic energy of Planck is half into 2 into v square, that is 100. So this will cancel out, this will cancel out, this will cancel out. So it will become equal to 800 plus 100 plus 100, that is 200. That is equal to 1000 joule. So total kinetic energy of the system is 1000 joule. Is this all right, student? Thank you. Today up to this. Okay. Rotational mechanics is over. Is this okay? Now you can practice questions from any reference. Good. Bye. Take care.